All right, everybody, let's have a look at this question. It says, find the points on the curve y equals x over x minus 1, where the tangent line is parallel to the line x plus 4y equals 1. Okay, as soon as I said parallel to, I know this is trying to give me information about slope. Okay, because anything that's parallel is going to have the same slope. So I'm looking for the tangent lines to this function that have the same slope, that's what parallel means, as this line. Well, to figure out the slope of this line, I'm just going to bring this over here, and I'm going to isolate the y. I'm going to put it into slope-intercept form. So I'll bring the x over, so negative x plus 1. And then I'm going to divide everything through by 4 to get the y by itself. So this is going to end up being negative x over 4 plus 1 over 4. And therefore, I know, okay, because I know that the slope, when it's written in this form, I know that the slope is going to be the leading coefficient. Okay, the slope is going to be negative 1/4. So that's what I'm looking for. I'm looking for the points along this curve where the tangent line is equal to negative 1/4. Well, tangent line, as soon as I start talking about the slope of the tangent line, I'm talking about a derivative. So now we're going to take the derivative of this expression up here, and because the last rule that I've gone over with my classes, it was the quotient rule, that's the rule we're going to use here. So here's my function. So y primed is going to be, and remember, actually I should probably review that rule first before I do this. Remember that if y is equal to f over g, then y primed is going to be equal to f primed times g minus f times g primed all over g squared. So in this particular case, because this is my function here, y primed is going to equal the derivative of the numerator, 1, times the denominator, minus the derivative of the denominator, or sorry, I should say this, minus the numerator, sorry, times the derivative of the denominator, which in this case is 1, all over x minus 1 squared. Okay, well now I want to simplify this a little bit, I want to clean that up. So it's going to be 1 times x, then 1 times negative 1 minus x, all over x minus 1 squared. Well, I like where this is going. This is going to get quite nice here because the x's are going to cancel. I'm just going to be left with negative 1 over x minus 1 squared. Okay, well now, if it's going to be parallel to that curve, remember the slope of that curve there was negative 1/4. So what I need is I need my derivative to equal negative 1/4. So y prime has got to equal negative 1/4, and that has got to equal negative 1 over x minus 1 squared. Okay, well, basically I can cross multiply here. I know that the negatives, by the way, are going to cancel out here, but I can cross multiply and make this x minus 1 squared is going to equal to 4. Now, couple of things here. I'm going to take the square root of this, okay? But remember, when I do that, because I got to take the square root of this 4 here, this could be positive or negative 2. Either one of those will work here. So either x minus 1 is equal to 2, or x minus 1 is equal to negative 2. Let's just see what happens there. If I bring that 1 over, I'm going to get x is equal to 3. And if I bring this one over, I'm going to get negative 1. Either one of those should work here. Okay. Now, I do see this negative 1 here, and I get a little bit concerned. Let's go back up to my function here. Where was my non-permissible here? The non-permissible is x could not equal positive 1. If I plug positive 1 into that, that's no good. But the negative 1 is okay. Negative 1 will work here. So now what I'm going to do is I got to figure out what the y coordinates are that correspond with these points. So let's start with 3. If I go up here and plug 3 in, I'm going to get 3 divided by 3 minus 1, so 2. So my answer here would be 3 comma 3 over 2. One more point here. If I plug negative 1 in, it's going to be negative 1 over, okay, negative 1 minus 1 will be negative 2. And in that case, because the numerator and denominator are both negative, this will end up being positive 1 over 2. And so those are the 2 points that we're looking for along that curve.